Hello, good afternoon. It's me again after lunch. I hope you guys had a good lunch and ready for some more section. My name is Frederico Simoes. I'm doing my PhD here at the University of Valladolid. And I'm mainly working with LiDAR going cloud. But this is a side project that, thanks Felipe for allowing me to do this. It's an interesting subject that I have also I would like to learn more, so I'm trying to understand how to improve this method. So, natural regeneration, it's a really important subject, and we must understand this context to improve the health and to improve the future forest. So it's a challenge for the forest to keep natural regeneration for many reasons. Nowadays, with climate change and all these problems, wildfire is decreasing the amount of some natural regeneration, and overgrazing, and also the climate change, more dry season. So everything this it makes the challenge of keeping natural forest healthy more complicated. Nowadays, researchers they go in the field, they try to identify, measure the seedlings, make the calculus evaluation of the abundance and all these parameters to compare and see if it's enough the natural regeneration. But this is really time consuming and expensive, and by installing some plots you don't have a really good view of the distribution and how is the structure of the areas with more seedlings, with more natural regeneration. It's my opinion. So what's my purpose? Why I'm interested? I want to search this. It's not for building a robot to do the hard work, to go there, stay in the floor, measuring small seedlings and counting a lot of seedlings. The idea is to make a smart system combining different algorithms, different knowledges to make the data more accurate and to improve the understanding of natural regeneration. So first of all, you need something portable. You cannot take a supercomputer with you and something that you can carry in the field and do the object detection. It's one of the goals, and after counting and mapping. This is my plan. But it's good to have a clear goal, because we have different natural regenerations, and I'm not planning to solve all the problems from natural regeneration. Of course, there is some hard work will be also necessary. Imagine to calculate some this right figure. It's much more complicated than a binary regeneration. And I start with the device. I choose this camera. It's an Oak D Pro with some power, computational power, 4 teraflops, and there's like 3 RGB cameras that you can have a stereoscopic vision, and also a sensor that measured distance, cannot say, but with the same idea of one LiDAR, that it sends like 4,700 pulses per second and up to 8 meters of distance. And also, there is an inertial measurement unit. This measure, IMU, it's used to control the pitch, yaw, and roll, the angles of the camera, so you can use this distance in a map. But we need also a computer. And I choose this one, NVIDIA Jetson, because this can be a future project also, with some GPUs, and I have some plans for this one. It's a small, powerful computer. And object detection. I was looking, this is a part of the artificial intelligence, the computer vision. And I choose the YOLO because it's a really light and designed for small and portable device, so we can have a really good object detection without much computational power to run this. YOLO, we have, it's being proved. When I started to do this, not just a few months ago, the last one was YOLO 7. Nowadays, there is the YOLO 8, but I already have trained my model, but it's still like, maybe in a few months, there's the YOLO 8 with more improvements. And the YOLO, what it does, it like breaks the image in some piece and gives some values for this piece, like some score. And after, it makes like boundary box around these scores, and you can filter the boundary box with certain precision, like you can set the threshold and say up to 70% or more, I consider as a match. And for my study, I used 200 pictures, and I used some data augmentation, flip, and crop. You take the same image and you crop in small size, just the areas you want, and this is done automatically. And also you flip the images so you can have more data. It's really data consuming. I'm supposed to have much more, but I have just 520 labeling pictures. Some pictures I have like 9, 10 seedlings, so this was my data. And I split 80% for training, 10% for validation, 10% for testing. This is a flip one. And I run the YOLO, and I had like this mean average precision is the parameter used to analyze the accuracy of the model. Was 72.2%. And recall 72.5%, and the precision 80.4. Here's some example. Of course, it's not 100%. So we can see here in the last the model ones here, there's like 3 seedlings that was not identified, and there's some issues, but it's a 72%, it's a good score, in my opinion. And after, I need to count. And I said, easy, just count the boundaries and it's done. But it's not like this. I'm using a camera, and usually when you see the training, when you see something on the internet, people, they have the camera stop, and they're counting people that are passing by. They're counting cars. They're counting different objects moving. And my trick was stopped, and I had to move and count these trees. So it was a problem. That I decided to include the mapping because I had object detection, and I had a laser in the camera. I could implement the SLAM, simultaneous location and map. This is the same technique used for LiDAR, and it uses points to create a map and a localization for the data. So it is using like matching points, and these matching points creates a new environment for the camera. And this is an example of a moving map. It's ongoing. I have to, the next step now, it's to validate this in a field, in a big area, that just not in tree or just a few seedlings like I did, but it's to go and take, for example, a big area, I don't know, like 100 meters and square, and scan 100 meters or something, but this will take some time. And also it would be really nice to add a LiDAR, not a big one, but a small one. There's like 32 meters LiDAR that you can add to the sensor. And also increase my database. It would be nice to have at least 1,000 trees, 1,000 seedlings, and also species. I train it just for pinus, and I think if I increase for other species, I could start to analyze some competition between seedlings and some other parameters. And also, I'm not measuring the height of the seedlings. I'm just counting and tracking that seedlings. As I have a measurement system, it will be nice to count this, to measure the height of the seedlings. And what I've learned so far, that artificial intelligence, it's not as easy as it seems to be. You see a video in YouTube, you do a course online, and you say, okay, easy. I will do it. I just have to change my object, and it's done. It's not like this. And it was good for problem solving, because every time you try to install a package, you try to change something, you have a problem. And also the ability to understand the code. And that's it. Thank you.